Setup check. All right, people, I believe we are live. Welcome back to Catalysis by Vedantu. My name is Pahul, and if I'm audible and visible, please write some yo in the chat box. You know the drill, yes. So, people, today we are going to continue the chapter of Ionic Equilibrium. In the previous few classes, what we've done is we've discovered the dissociation of weak acids and bases. We've also seen how to define the pH scale. We've also seen how to write the value of pH in the cases of strong acids and strong bases, even if they are dilute. And then in the process of explaining when you have dilute acids and you have to take into consideration the concentration of water as well, that is called common ion effect, because the H positive concentration given by both of the reactions is very similar. Yeah, so today what we'll do is we'll build onto that idea. We'll use the idea of two different reactions giving you the same ion and then using the common ion effect in our calculations. So the first two questions that we have are not related to common ion. The further two, three questions that I've taken are relevant to that. So पहले तो ये करते हैं. This was the question that I had given you here. So can you guys tell me what's the answer? Solution number 1 has pH equal to 4. Yes. Now pH equal to 4 implies your H positive's concentration is equal to 10 to the power minus 4. Yeah. On the other hand, the second situation is pH is equal to 10. Now some of you would be like, H positive is equal to 10 to the power minus 10. Let's add both of them, calculate the pH, and you would give me an answer like 4 point something something. Yeah. But the thing is, do you realize that this particular solution is basic in nature? Yeah. Your pH is greater than 7. It's a basic solution. So over here, instead of talking about the H positive concentration, we should be talking about the OH negative's concentration, which is equal to 10 to the power minus 4. Yes. है ना जी? So इस case में, in the top case, your OH negative concentration, even if you want to write, is equal to 10 to the power minus 10, and over here the H positive concentration, if you want to write, is equal to 10 to the power minus 10. ठीक है? Got it? So people, the thing over here is, when you mix these, when you mix these solutions together, neutralization will happen. H positive will combine with OH negative, neutralization will happen. So this is basically an acid-base reaction. Do you realize that? This is basically an acid plus base reaction. What does this give you? This gives you neutralization. Isn't it? Same amount of acid, same amount of base. So overall at the end, neutralization will happen. Excess of H positive, excess of OH negative will go back and turn into water. Yes. So finally the concentration of OH negative and H positive will be equal to 10 to the power minus 7. So overall over here, the resulting pH will be equal to 7. Because we are assuming that the reaction is happening at 25 degrees Celsius. ठीक है जी? तो यहाँ पे आंसर आएगा 7. If you give me the answer as 4.3 or something like that, you are wrong. ठीक है? Got it? अब गलती मत करना दोबारा से. So let me see how many of you actually gave me the correct answer in the previous class. Just give me one moment. Just opening the comment section from the previous class. Give me just one moment. Here we are. यहाँ पे अपन करेंगे comment section sort by newest first. And let's go down. नीचे चल के देखते हैं क्या चल रहा है यहाँ पे. Okay, so again, Manasvi, very good job. Kalash, absolutely correct. Priyanshu, correct. Aviral, you've edited your answer. I hope you gave it correct in the first go. Manasvi, you as well. चलो ठीक है, I'll still consider your answers. और Navneeta, absolutely correct. Yogini, yes, that is correct. Avik, correct job. Krish, absolutely correct. बढ़िया. Lekha, correct. Abhilash, correct. Tushar, you are correct. ठीक है जी. So a lot of people gave me the wrong answer, and I hope now you understand that whenever there is pH mentioned, you have to be careful whether it's an acid and a base, and then move forward with the calculation. Cool? Got it? चलो जी, अब बढ़ते हैं थोड़ा सा आगे. Let's do this question now. Calculate the pH of 0.1 molar solution of CH3COOH if its degree of dissociation is just 2%. Let's try to do this question. Okay. तो यहाँ पे क्या होगा? You have a reaction CH3COOH which is breaking apart into H positive plus CH3COO negative. ठीक है? Got it? Now, initially, our concentration over here is given as 0.1. At equilibrium, what's going to happen? At equilibrium, the concentration will be 0.1 into 1 minus alpha. Yes? Remember? 1 minus alpha और यहाँ पे आ जाएगा 0.1 times alpha and यहाँ पे भी आ जाएगा 0.1 times alpha. This is what it's going to be. Yeah? So, I can write my K equilibrium is equal to कुछ दे रखा है यहाँ पे K equilibrium की एक्चुअली जरूरत नहीं है. You don't need to calculate the K equilibrium because the H positive concentration is 0.1 times alpha. Yes, that's what it is. H positive concentration is 0.1 alpha. Now let us check if this H positive concentration is considerably higher than 10 to the power minus 7. We don't need to consider water. If this is much lesser than 10 to the power minus 7 or comparable to 10 to the power minus 7, then we will need to consider the contribution of water as well. है ना जी? समझ रहे हो बात? अगर ये नंबर आता है 10 10 to the power minus 7 से ज्यादा तो वाटर की कंट्रीब्यूशन की कोई जरूरत नहीं है. वाटर्स कंट्रीब्यूशन विल बिकम नेग्लिजिबल. But if this number is very close to or less than 10 to the power minus 7, then we have to consider the contribution of water as well. ठीक है? चमकी बात है ना? तो करते हैं थोड़ा सा. Try it out. या करो जरा ट्राई करो इसको. कितना आया आंसर? वेरी सिंपल. आई डोंट थिंक देयर इज एनीथिंग कॉम्प्लिकेटेड अबाउट इट. H positive concentration is equal to 0.1 into 2%, that is 2 by 100. So this is equal to 2 into 10 to the power minus 3. 2 into 10 to the power minus 3, as you can see, is much greater the number compared to 10 to the power minus 7. So because of this observation, we can neglect the contribution of H positive via water. पानी जो भी H positive दे रहा है उसकी यहाँ पे सोचने की जरूरत ही नहीं है. ठीक है जी? So 2 into 10 to the power minus 3 is greater than 10 to the power minus 7. Therefore, we don't need to consider the contribution of water. So simply P of H will be equal to what? This is going to be equal to minus log to the base 10 of this particular number. 2 into 10 to the power minus 3. So this is equal to 3 minus log 2. कितना आ जाएगा दोस्तों? How much is this? 3 minus log 2. Yeah, approximately 2.7. As simple as that. ठीक है जी? Approximately 2.7 आ जाएगा. ठीक है? Got it? 3 minus log 2 हो जाएगा ना. log 2 is 0.30 something something. So the answer should be 2.7. Okay, cool. I hope you understand this idea. So very simple. Okay, very simple concept. Nothing too difficult about it. Now let us move forward and let's solve this question. You must have noticed that my approach for most of the chapters of physical chemistry is we solve questions, and via questions we learn how to deal with the theory. That's how chemistry is supposed to be done. Okay, so what is the HCOO negative concentration in a solution that is both 0.15 molar HCOOH and 0.02 molar HCl? What is the pH of this solution? Let's try to understand what is happening over here. There are in fact two reactions that are happening. Read the question. I'll give you 10 seconds and then I will write things down regarding the mathematics of this question. ठीक है, देख लिया. Chalo. So now there are two reactions that are happening. One reaction is a straightforward reaction coming out of a strong electrolyte. So you've got H positive over here, plus you have Cl negative over here. Yes. ठीक है जी. So what is this given as? This is given as 0.02 molar. This is initially. Finally, of course, since this will turn into 0 because it's a strong electrolyte, you are going to get 0.02 moles of H positive and 0.02 moles of Cl negative in 1 liter of solution. Yeah, that's what molarity is. So this is one of the reactions that is happening. There is another reaction that we need to consider. Yes, there is another reaction that we need to consider, and that is HCOOH, formic acid. Okay, this particular species is formic acid. It is yet again a weak acid. So in a weak acid, you will have an equilibrium. This is what you will get at the end. You will get some H positive, you will get some of the conjugate base. Initially, this guy is given as 0.15 molar. Okay. Now at equilibrium, alright, now at equilibrium, this will be 0.15 minus, इसको ऐसे लिख देते 0.15 into 1 minus alpha. Yes. Alpha is basically the percentage of the initial amount that has reacted. If you don't understand what is degree of dissociation, 2 to 3 classes back I have explained exactly what it is. Go back and watch that class please. यहाँ पे क्या आ जाएगा 0.15 into alpha और यहाँ पे भी आ जाएगा 0.15 into alpha. Cool? Got it? Now my dear friends, in this entire picture, okay, in this entire picture, what is the total H positive concentration? In this entire picture, what is the H positive concentration? Total H positive concentration is equal to this plus this. है ना जी? This concentration has to be taken care of. This concentration also has to be taken care of. So basically, there is a common ion in both of these reactions. Most of you must be thinking that, sir, why aren't you considering the reaction with water? Because water's contribution towards H positive will be very small when I compare it to 0.02. Yeah, 2 into 10 to the power minus 2 is a much higher number compared to 10 to the power minus 7, which is generally what the contribution of H positive via water is. Okay? So the thing is, over here you need to consider only these two reactions. ठीक? Got it? ये दो reaction consider करेंगे. Fine. Now, this H positive concentration that we've got will be equal to 0.02 plus 0.15 alpha. Now there are two ways in which you can solve this question. One way is you can try and calculate the alpha and then do the exact calculation. Okay? एक तरीका ये है कि यहाँ पे alpha calculate करने की कोशिश करो और फिर exact calculation करो. Let's try to do that exact calculation and then we'll understand why we don't actually need to do it. ठीक है? So I'm going to erase a lot of things over here. I hope you've written it down. एक बार देख लो इसको. काफी चीजें मैं erase करने वाला हूँ. चलो. So I'm going to erase the top part of this particular page. यहाँ पे थोड़ी सी calculation करने की कोशिश करते हैं. Yes. So over here, can I say that Ka is equal to H positive concentration into HCOO negative concentration divided by HCOOH concentration, isn't it? ठीक है? Now, whenever we are writing this equilibrium equation, total concentration of H positive in solution has to be taken. Total concentration of HCOO negative in the entire solution has to be taken. That is the mathematics behind common ion effect. Over here, H positive concentration, you cannot simply take 0.15 alpha. H positive concentration over here has to be the total concentration and that is this big number. ठीक है जी? पूरा ये नंबर लेने का है, तभी बात बनेगी. Alright. So over here, what we will do is, we will write H positive concentration. Total concentration is 0.02 plus 0.15 alpha okay, into HCO negative's concentration, that is just 0.15 times alpha. तो वो यहाँ पे सीधा लिख देंगे, थोड़ा आराम से लिखता हूँ मैं, just with a smaller handwriting. Yeah, this is the H positive concentration multiplied with the HCOO negative concentration divided by HCOOH concentration, that is going to be 0.15 into 1 minus alpha. ठीक है? Got it? Okay. Now people, I'm going to erase this part of the equation. ये वाला पार्ट मैं इरेज करने वाला हूं ताकि तो हम थोड़ा आगे बढ़ पाए. Okay, I'm going to erase this now. People, now remember, this is something that we did in the second class of ionic equilibrium. Since HCOOH is a very weak acid. Can you see it's a very weak acid because the Ka is less than 10 to the power minus 3. If Ka is less than 10 to the power minus 3, you can easily say that it's a very weak acid. And since it's a very weak acid, this implies alpha is very less. यहाँ पे मैं I'll write it mathematically. This implies alpha is much less than 1. ठीक है? So from here, what are the assumptions that we can do? We can say that from here, therefore, 1 minus alpha is approximately equal to 1. Yes, ये बोल सकता हूं मैं. 1 minus alpha is approximately equal to 1 because alpha is very, very small. Alpha is a very small number. Now, my dear friends, one more approximation to make life easy. This approximation is to make life easy. You can do an accurate calculation if you want. Even if you don't do an accurate calculation, the answer will be very close to the accurate idea. How do we make our life easy? Look at this term. If I take this term like it is right now, the entire equation will turn into a quadratic equation. अगर मैं ऐसे कैसा ले लूँ तो पूरा का पूरा quadratic बन रहा है यहाँ पे. Who's going to solve a quadratic equation? Let's do this. 0.02 plus 0.15 alpha is approximately equal to 0.02. Whatever term gets multiplied with alpha, let's say it is useless. Okay. Alpha will be what? Less than 5%, less than 0.05. है ना? 0.05 into 0.15, very small number. You can neglect it in front of 0.02. Maybe it makes it 0.021. ज़्यादा से ज़्यादा क्या हो जाएगा? Yeah. So the thing is, since we are assuming that alpha is a very small number, okay, we are assuming that alpha is a very, very small number. Therefore, this term that is multiplied by alpha can also be neglected. This makes our life easy. So using these two approximations, I'm gonna change a few of the things mentioned over here. इसको भूल जाते हैं and let's forget this jazz as well. ठीक है? This approximation and this approximation, put it over there. Now calculate the value of alpha. It's going to be much more simple. करो अब calculate कितना आ जाएगा? What does alpha come out to be? बताओ. ठीक है, बस यहां से कैलकुलेट कर लो अल्फा. हाउ मच डज दैट कम आउट टू बी? अल्फा इज इक्वल टू 1.8 इंटू 10 माइनस 4 डिवाइड बाय 0.02. बहुत ही छोटा सा नंबर आएगा. या तो यहां पे मैं लिख देता हूं. लेट्स जस्ट कैलकुलेट अल्फा. सो अल्फा इज इक्वल टू 1.8 इंटू 10 माइनस 4 डिवाइडेड बाय 2 इंटू 10 माइनस 2. तो यहां से बच जाएगा 10 माइनस 2. And this is equal to 0.9 into 10 minus 2, और बेसिकली देखा जाए तो 9 into 10 minus 3 है ना? यही आ जाएगा 9 into 10 minus 3 alpha. See, very small number है ना? Alpha is a very small number. Since it's a very small number, this part can also be neglected compared to 0.02. Okay. So since the answer comes out to be very small, this assumption is a good assumption, valid assumption. ठीक है, तो ये आ गया यहाँ पे. So you can multiply this with alpha to get the, sorry, this is alpha, so you can multiply this with 0.15 to get the concentration of HCOO negative, है ना? तो HCOO negative concentration, which is asked in the question, is simply equal to 0.15 into 9 into 10 to the power minus 3. तो ये करते रहो calculation, you can do it. Okay. Now, my dear friends, let's calculate the pH. Do you realize pH calculation is very simple? Over here, this is the concentration of H positive. This is the concentration of H positive, and we have neglected this idea. Because alpha is so small, let's neglect the contribution of H positive given by the formic acid. Formic acid की वजह से जितना भी H positive आ रहा है उसको neglect करो, भाड़ में जाए. Yeah. So pH over here is simply equal to minus log to the base 10 of H positive concentration that can be approximated to 0.02. बात खत्म. As simple as that. ठीक है, तो ये कितना आ जाएगा? minus log to the base 10 into 2 into 10 to the power minus 2. ये आ जाएगा ना? This is equal to 2 minus log 2. Approximately 1.7. Yeah, so pH of the solution is approximately 1.7, and this pH is being contributed by the HCl. HCOO negative in front of HCl is pretty much useless. This is the practical application of common ion effect. Understood? This is the practical application of the common ion effect. What is happening over here? In front of the strong acid, the weak acid is neglected. Yeah, because you are adding more H positive via the strong acid, the weak acid's equilibrium goes back. The weak acid's equilibrium is driven backwards. The contribution of H positive by the weak acid is even more negligible. As simple as that. Okay? You can try and solve the quadratic equation as well. You will pretty much get the same answer. आप चाहे कोशिश कर लो. Okay. Balaji is saying solving that quadratic equation gives 8.5 into 10 to the power minus 3. Pretty good approximation. 9 into 10 to the power minus 3. Yeah. Balaji is saying that if you solve the quadratic equation, the alpha comes out to be 8.5 into 10 to the power minus 3. तो ठीक है ना. 0.009, 0.0085, same thing. Cool. So this is how we can neglect the concentration of H positive given by the weak acid. Nice question. Yes. So this is common ion effect, people. यही होता है common ion effect. There's nothing else. Okay. This is what common ion effect is, and I'm pretty sure you understand. It's very simple. Sorry. ठीक है. तो चलो. If you guys want to spend more time on this question, just rewind the video and watch it again. I'm pretty sure that will also help you build a little bit more knowledge. Now let us talk about mixing two weak acids. This idea is important because direct questions from this idea will come in your examination. I guarantee you, especially in NEET and JEE mains. Direct question aa jayenge. Two weak acids, their K equilibrium will be given. You have to calculate the pH. I'll show you how to do that. ठीक है? चलो. Ready? If you are ready, write ready in the chat box. I can see a lot of people just die out. Class के बीच में सो जाते हैं सारे लोग. If you are ready, write ready in the chat box. Let me see. Ankit is saying, why does common ion defect decrease solubility? I'll tell you about that, Ankit, when we come to solubility. उस पे भी आएंगे. Okay, don't worry. Someone is asking, is this chapter important for JEE? पागल है क्या मैं जो करवा रहा है? Yes, it is important, my friend. Yeah. Okay, awesome. I can see a lot of people writing ready. Srinivas, Ayushi, Firepower, Divyasa, Yogini, Alok, Rajesh, Balaji. Okay, lots of people. Nice. Mixture of two weak acids. करें इसको. देखो. Let's take two acids. Let's take HX and let's take HY. Okay. Now, since they are weak acids, both of them will be equilibrium reactions. H positive plus X negative. And this will give you H positive plus Y negative. ठीक है? Okay. initially, let's say I take concentration C1, let's say I take concentration C2. At equilibrium, what's going to happen? Every one of us knows what's going to happen. क्या ही होगा? क्या ही हो जाएगा यहाँ पे? This will be C1 into 1 minus alpha, C1 alpha, C1 alpha. Yes, this is something that we've been doing till now. But let me tell you, for this analysis, writing alpha is going to be a little difficult because this will have a different alpha, this will have a different alpha. So we'll be dealing with different concentrations, different degrees of dissociation, different K equilibrium. It becomes a little too complicated. So to solve the complication, let's write it in a different manner. थोड़ा अलग से लिखेंगे. This is something that we have been doing in chemical equilibrium. Let's write it as C1 minus X. X is basically your C1 times alpha. Yeah. C1 into 1 minus alpha. I have just written it as C1 minus X. So X becomes C1 times alpha over here. So no need to worry about it. We're just writing X over here for simplicity. I'll tell you why. C1 minus X, this becomes X, this becomes X. है ना जी? And on the other side, this will be C2 minus Y. ठीक है? Got it? So we are assuming that X amount of it reacts. Since the stoichiometric coefficient is 1, 1, 1, X amount will be created, Similarly over here, Y amount reacts. Since the stoichiometric coefficients are 1, 1 and 1, Y is created. Okay? So my dear friends, from here I can write K1. Okay? For Hx I will write K1, for Hy I will write K2. Let's write the equations. K1 will be equal to concentration of H positive into concentration of X negative divided by the concentration of Hx. Over there, what can we write? We can write concentration of H positive into concentration of Y negative divided by the concentration of Hy. So till now we haven't mixed either of these. Yeah. Till now we are just doing this separately and we are doing this separately. Now I will write something. You have to tell me whether that is correct or not. ठीक है, मैं यहाँ कुछ लिखूंगा, वो बताना है correct है कि नहीं है. K1 is equal to X into X divided by C1 minus X. Is this correct? Yes or no? Give me the answer in yes or no. Is this correct or not? Krishna, just read the title of this video. Balaji is saying no, this is wrong. Priyanshu is saying this is wrong. Okay. Neetu is saying this is wrong. Pradeep is saying this is wrong. I hope you understand that yes, this is incorrect. Why is it incorrect? Because I have to take the total concentration of H positive. Mixture of two weak acids, these two reactions are happening simultaneously. In the equilibrium concentration of H positive, I have to take the consideration of this reaction and of this reaction as well. Yes, I have to take into consideration the contribution of H positive from both the reactions. दोनों reactions से H positive आ रहा है ना भैया. So over here this is incorrect. What I should write, okay, H positive's concentration is how much? X plus Y. X plus Y. You have to take into consideration both the concentrations. Total concentration लेना है अपन ने. That is what common ion effect is. Yeah. Practically speaking, what is happening? If this originally gives a number of H positive, this originally gives a number of H positive. When you mix them together, you have more H positive now. Yeah. For this reaction, you are adding more H positive. For this reaction, you are adding more H positive. So the thing is, both the reactions will be driven backwards. Samjha? If you consider this to be the main equilibrium, it was supposed to give you some H positive, But since this reaction is also giving you some H positive, product in excess reaction will go back. Similarly, for this reaction, you were supposed to give it some H, this was supposed to give you some H positive, but you give it extra H positive, product increases, reaction goes back. So when you mix both of these weak acids, both of them will not dissociate completely. Yeah, they both will not dissociate to their full potential. They will be affected by the presence of H positive in both the reactions, common ion effect, and this is how we are considering it mathematically. तो K1 को क्या लिखेंगे यहाँ पे? H positive's concentration, that is X plus Y, X negative concentration is X, sorry, HX concentration is C1 minus X. या ठीक है, बात बनती है. Now my dear friends, can I approximate this to be as good as C1? Since the dissociation is very small. See, anyway we're talking about weak acids, right? Weak acid में नीचे क्या करते थे? We used to do C1 into 1 minus alpha, neglect alpha. So C1 minus X, since X is going to be a very small number, X is going to be a very small number because it's a weak acid, we can simply call it C1. ठीक है, तो यहाँ पे K1 क्या आ जाएगा? X plus Y into X divided by C1. Okay. On the right hand side, similarly, let's write the same thing for K2. H positive's concentration combined is X plus Y. This is Y and this is C2 minus Y, approximately C2. ठीक है, सो यहाँ पे मैं लिख दूंगा K2 is equal to X plus Y into Y divided by C2. Please write these two things down. Saran, did you watch the last class, my dear friend? If you did not watch the last class, you won't be able to understand this one. ठीक है, योगिनी, yes, you are absolutely correct. चलो जी, यश, don't think about it as a problem. It's a natural process. चिल मारने का. चलो करें आगे. Yeah, let's do it. So what I will do right now is I will erase this part so that we have more space to do some calculations. Yeah. So people, my final goal over here is to calculate pH. Okay. My final goal over here is to calculate pH, and we have just realized that in this entire scheme of things, H positive's concentration overall is equal to X plus Y. So if I am somehow able to calculate a number for X plus Y, I will get H positive concentration and then I will take the log of that to calculate the pH. तो करते हैं कुछ इन दोनों equations में, in both of these equations, let's take the constants towards the, let's take the concentrations towards the left hand side. Okay, so C2 को यहाँ लिख दूंगा मैं and C1 को यहाँ लिख दूंगा मैं. ठीक है, fine. Now people, this is equation 1, this is equation 2. Let's add both of these equations. Okay, let us add both of these equations together. What will we get? We'll get C1 K1 plus C2 K2 is equal to X plus Y into X plus Y into Y. यहाँ पे take X plus Y common. What will you get? You will get X plus Y into X plus Y. Yeah, as simple as that. दोनों चीजों को ऐड करो, X plus Y कॉमन लो, ये आ जाएगा आपके पास. Fine, got it. So my dear friends, from here I have the value of X plus Y. X plus Y very simply is equal to root of C1 K1 plus C2 K2. And this is your total concentration of H positive in this mixture of weak acids. Do you see this is a very beautiful equation? Yeah? Do you see it's a very beautiful equation? Write it down, then I'll give you a conclusion and then we'll solve a question related to this idea. लिखो इसको. लिख लिया दोस्तों? Did you write it down? चलो. So now let us conclude this idea. Okay, I'm going to erase everything now. If you have a mixture of, okay, if you have a mixture of n number of acids, let's say mixture of 4 acids, okay, and what acids are we talking about? 4 weak acids. The final H positive concentration is going to be equal to root of C1K1 plus C2K2 plus C3K3 plus C4K4. See how beautiful ionic equilibrium is as a chapter. Yeah, H positive concentration is equal to root of C1K1 plus C2K2 plus C3. What is C1? Concentration of the acid that you've taken. What is K1? Acid dissociation constant of that acid. ठीक है? So if you have, let's say, n number of weak acids, just keep adding this till CnKn. Just take the root of the entire thing. Beautiful. Yeah, काफी सही, अच्छा सा result है, very beautiful result. So now using this idea, let us solve a question. करो इसको. Very simple question now. Yeah, कुछ ज़्यादा ही simple question हो गया ये अब. What's the H positive concentration of the mixture? And ultimately, what is the pH of the solution? Let's solve it. There are 2 weak acids, HCOOH and HOCN. ठीक है? Sorry. Ka for both the acids is given to you. Initial concentration of both the acids is given to you. Khatam baat. H positive concentration is equal to root of C1K1 plus C2K2. Yeah, so C1 is 0.1 into K1 is 1.8 into 10 to the power minus 4 plus 0.1 into 3.3 into 10 to the power minus 4. लो भाई ये बात तो यही काफी सिंपल हो गई. Yeah. This is equal to, in the root itself, let's take some things common. 0.1 and 10 to the power minus 4 can be taken common, yeah? So 0.1 into 10 to the power minus 4 can be taken common. What you have over here is 1.8 plus 3.3. ये क्या चीज़ है? This is as good as 10 to the power minus 5, पर चलो कोई ज़रूरत नहीं उसको लिखने की. Let's write as 0.1 into 10 to the power minus 4 अभी के लिए. So 1.8 plus 3.3 कितना आ गया? 5.1. Yes, ये हो गया 5.1. तो बस यही करना है अपने को. This is what we have to do. कर लो कैलकुलेशन. So this can be written as थोड़ा सा अप्रोक्सीमेशन करते हैं ना. This can be written as root of 10 to the power minus 4. तो इसको तो बाहर लिख के जा सकते हैं. This root of 10 to the power minus 4 will be 10 to the minus 2. This is multiplied with 0.1. Okay. एक ना थोड़ी इंटरेस्टिंग चीज करते हैं. I'm going to write this 0.1 as 1 by 10. Okay, and this is into 5.1. 5.1 को let's write it as 51 by 10. Okay, ठीक है. तो यहां से क्या हो गया? 10 और 10 मिल जाएंगे यहां पे. This becomes 100. This entire thing becomes 10 to the power minus 6. Just manipulating. Yeah. So this entire thing basically is as good as 10 to the power minus 3 into root of 51. 7 into 7 is 49. Yeah. So this is approximately equal to 7 point something 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 into 10 to the power minus 3. Approximately. Yeah. So chalo, ये हो गया. This is the H positive concentration. You can calculate the pH as well. Log 7 निकाल के pH बना लो. Yeah. pH will be 2.1 something. pH will be 2.1415, है ना जी? चलो जी, या pH अप्रोक्सीमेटली 2.14 2.15 के आसपास आ जाएगा. डन. लाइफ इज सिंपल. काफी सिंपल क्वेश्चन, या. सो सच क्वेश्चंस कैन डायरेक्टली बी आस्क्ड इन नीट एग्जामिनेशंस एंड जेईई मेंस एग्जामिनेशन. जेईई एडवांस्ड में इतना सिंपल नहीं आएगा. दे वोंट बी दिस सिंप्लीफाइड. इट विल बी अ लिटिल मोर कॉम्प्लिकेटेड इन जेईई एडवांस्ड, बट अगेन it's an important concept to remember. Nice. Charishma is asking where is Billu. Billu is in the room. Billu and Leona are inside the room because if they are here, they are going to throw away everything and the class is going to stop 20 times. एक बार हुआ है मेरे साथ. Nadesh, look at the Ka values, brother. Yeah, if the Ka value is less than 10 to the power minus 3, it is a very weak acid. As simple as that. Chalo ji. Now, my dear friends, this is the last concept that we will discuss in today's class. This also involves the idea of the common ion effect, but again, we end up neglecting a lot of things. Analysis of a diprotic acid. Okay. What's happening inside a diprotic acid? Let's take the example of H2CO3 that is given over here. We'll write the same thing again to make it simple for you to understand. H2CO3. This has two H positives that it can give away, not just one. So what we will think is that this gives away its H positives step by step. ये अपने H positives step by step देगा. Let's try to do that. In the first step, how is it going to get rid of the H positive? Is going to give you H positive plus HCO3 negative. Now this HCO3 is going to act as the second acid. Okay, so HCO3 negative आया यहाँ पे, and this is going to break apart into yet another H positive, and CO3 2 negative will be formed. Fine. So first step, one H positive is released. Second step, one H positive is released. Now, my dear friends, using a little bit of your brain and using the information that's given on the page, can you tell me, getting this H positive versus getting this H positive, which one is easier? Okay, this is H positive number 1, this is H positive number 2. Which one is easier to obtain? Which reaction is easier for you? Is it easier for me to get the first H positive, second H positive is hard, or the other way around? Batao, what do you think? What do you think? आपको क्या लगता है? Ayush, I try to look at the chat box whenever I can, although I hope you understand that I can't just look at each and everything that you guys ask, yeah, because there are so many people that are live at the same time and I have to teach as well. So a bunch of people, Neetu, Avik and Balaji and Kalash and Firepower and Shivam, Ishani, Ayushi, a lot of people are saying that it's easy for me to obtain the first H positive. Isn't that obvious from the equilibrium that is given? Arey, value dekh lo yaar. I'm giving you a cheat code right on the screen. See, from these values, these are experimentally determined values. From these values, we can see that it is easier for me to abstract the first proton. The second proton, not very easy to abstract. Yeah, higher equilibrium constant means easier forward reaction. Lesser equilibrium constant means harder forward reaction. Why is it harder? Can you theoretically explain? Can anyone theoretically tell me why it is harder for me to obtain the second H positive? See, the thing is, this is already a negatively charged species. To take away a positive charge from a negatively charged species is going to be very difficult, isn't it? Taking out a positive charge from a neutral species, okay, fine. It's not a very good idea, but still it can happen. But there is a negatively charged species now. It wants more positive charge. But what you are doing is you are taking away positive charge from it. It's going to be difficult. Yeah. I'll speak that thing in Hindi as well. ये पहले से नेगेटिव चार्ज है भैया. नेगेटिव चार्ज कहीं है तो उसको पॉजिटिव चार्ज चाहिए. बट आप क्या कर रहे हो? उससे पॉजिटिव चार्ज खींच के ले जा रहे हो. तो ऑब्वियसली मुश्किल होगा. Yes. So abstracting the second H positive is always difficult. ठीक है. So this entire thing is written over there. I'm gonna erase whatever I have written over here, and let's Observe the mathematical idea. What's the mathematical idea? The mathematical idea over here is that K2 is much less compared to K1, because it is very difficult to abstract the second proton from an already negatively charged species. ठीक है, ज़्यादा जोर लग जाएगा. All right. Now, my dear friends, we will consider these two reactions as separate reactions and then combine them via common ion effect. Are you ready to do that? Correct? Chalo. So let us say, एक second, let me see if I have a blank page. Black page है मेरे पास. रुको. Let me create a blank page. अच्छे से करते हैं इसको. Yeah. Just a moment. Let this black bar go away. चलो जी, करिए हुण. Let's do it. Let's take H2 CO3. This breaks apart into H positive plus HCO3 negative. Initially, let us say I have taken concentration C1. ठीक है जी, let us say I have taken concentration C1. So at equilibrium, I will assume that this is C1 minus X. Again, for simplicity, let's assume X. We'll talk about degree of dissociation when it is asked in the question. ठीक है, तो यहाँ पे भी C1 minus X, this will be X, this will be X. First reaction is over. Now let us write the second reaction. Second reaction is when this starts acting as the acid. Yes, these are the two reactions that are happening. Fine. Now, can you tell me what will be the initial concentration of HCO3 negative? All the HCO3 negative is being created by the first reaction. So the initial concentration of HCO3 negative is going to be X, isn't it? ये तो यहीं से create हो रहा है ना. So what are we thinking? We are thinking that this reaction happens first and then this reaction happens. That's how we are thinking, although they are happening simultaneously. But just for calculation, just for thought process, it's better for us to think that this reaction happens, then this reaction happens. Okay? So initially, I can say that HCO3 negative is X. Finally, this is going to be X minus Y. This is going to be Y, this is going to be Y. ठीक है जी? Got it? Awesome. Now, let us try to write the generic forms of the K equilibriums in both of the cases. Generic form, ठीक है? So K1 is equal to concentration of H positive into concentration of HCO3 negative divided by the concentration of H2CO3. ठीक है. सेकेंड केस में K2 is equal to concentration of H positive into concentration of CO3 2 negative divided by the concentration of HCO3 negative. ठीक है, ये लिख सकते हैं अपन दोनों केस में. First equilibrium constant, second equilibrium constant. Now, let us fill in the exact values. Let us fill in the exact values. यहाँ पे इसको divide कर देते हैं. What is the total concentration of H positive in this entire system? As you already know, common ion effect has to be taken care of. What is the concentration of H positive in this entire situation? In this entire situation, H positive's concentration is equal to X plus Y. What is the final concentration of HCO3 negative? Is this the final concentration of HCO3 negative? No. Out of that X, Y amount is being used. है ना? So you basically over here have to write the final concentrations of everything. This is just step-by-step things that we've written for our own selves. Over here in this equation, we have to write the final things. So finally, H positive is X plus Y. Finally, HCO3 negative is X minus Y because Y amount of it is used. ठीक है? तो यहाँ पे आ जाएगा X minus Y. Divided by H2CO3's concentration is C1 minus X. यहाँ पे भी लिख देंगे H positive concentration is X plus Y, CO3 to negative concentration is Y, HCO3 negative is equal to X minus Y. अब दोस्तों अब sorry, my throat is a little sore today. Up over here we will write some facts using which we will write some approximations and make these easier. थोड़े facts लिखेंगे और फिर इन चीजों को और easy कर देंगे. Yeah. Fact number 1. K1 is very less. दिख रहा है यहाँ पे K1 is very less. 10 to the power minus 7 something था. It was written on the previous page. Yeah. K1 was 10 to the power minus 7 something. K2 was 10 to the power minus 11 something. Both are very small numbers. So my dear friends, since H2CO3 is weak, okay, or I should say very weak, can I say C1 minus X is approximately equal to C1? बोल सकता हूँ ना. This is what we've been doing till now, है ना. C1 minus X, X is going to be what, 0.0 something percent. I mean, not 0.0 something percent. It's going to be a 0.05, 0.04 number, है ना. Very small number subtracted out of the initial amount. So again, C1 minus X is approximately equal to C1. तो यहाँ पे correction करते जाते हैं, okay? You guys can write it again. I'm just going to do correction on the board. You guys can write it below the main thing in your notebooks, okay? So यहाँ पे I can neglect this X. ठीक है, ये हो गया first assumption. Now, my dear friends, let's do the same approximation over here. Let's do the same approximation over here. Okay, correct? Since HCO3 negative is very weak, Y is going to be very less compared to X. I can say X minus Y is as good as X. ठीक है, ये हो गया एक और simplification. X minus Y is as good as X. If X minus Y is as good as X, I can also say X plus Y is as good as X. Why not both ways? है ना जी? If X minus Y is as good as X plus Y is also as good as X. तो यहाँ पे what are the things that we can neglect? We can neglect Y with respect to X. We can neglect Y with respect to X. We can neglect Y with respect to X. Y on its own can't be neglected. Yeah. Y when it adds to X can be neglected. Y on its own can't be neglected. Y on its own is a very small number. When it multiplies to something else, it will turn everything into a small number. But when you add Y to something, then you can neglect it. So Y can be neglected compared to X. So finally, after all these approximations, let's write the forms of these two equations once again. यहाँ से आ जाएगा x into x आ जाएगा, यहाँ पे ऊपर आ जाएगा x square by c1. यहाँ पे क्या आ जाएगा? Simply equal to y. k1 is equal to x square by c1. k2 is equal to y. My dear friends, y is equal to the concentration of CO3 to negative. And X is equal to the concentration of H positive, because Y compared to X is very small. So X plus Y is as good as Y. So the contribution of H positive in this entire mixture is only because of the first reaction. Second reaction, you can neglect the concentration of H positive because of that. So ये हो गया आपका common ion effect in the case of a polyprotic acid. Diprotic acid is case में because it has 2 protons. If it has 3 protons, triprotic. If it has too many protons, polyprotic acid. ठीक है, so ये हो गया analysis. Just spend 5 more seconds and then I'll give you the homework. Cool. So I hope you've observed whatever we've written. What is your homework? Homework is to do the same thing for a triprotic acid. Do this analysis for a triprotic acid. ठीक है, so let's take H3PO4. H3PO4 लेके आपने सेम चीज करनी है. H3PO4 break it apart into H2PO4 negative. H2PO4 negative break it apart into HPO4 2 negative. HPO4 2 negative break it apart into PO4 3 negative. Now these three steps that you've written, write K1, K2, K3. C1 minus X, X, X. X minus Y, Y, Y. Y minus Z, Z, Z. And then write the equilibrium reactions. And then finally write the approximations. That C1 is much greater than X, is much greater than Y, is much greater than Z. That's how you have to solve this particular case. तो ये आपका homework हो गया. As simple as that. Next class is tomorrow. Tomorrow at 7 p.m. So in the next class, that is tomorrow at 7 p.m, what we are going to do is we will solve this very quickly, and then we will move on to the basic idea behind buffer solutions. Tomorrow's class is going to be interesting. We'll talk about buffer solutions. We'll talk about the theory behind buffer solutions, and if time permits, we will also get into the mathematics of buffer solutions. It's a very interesting topic, and buffer solutions, the theory is a little hard to understand, but practically it's just equilibrium reactions written here and there. Mathematics of that is also going to be fairly simple. Cool. So people, that's all for today's class. आज की क्लास में यही करना था अपने को. Srija is saying, sir, K1, K2, K3 values, you don't need to worry about that, Srija. That will be given to you in the question whenever there is one. Sorry. Kanika is saying, please give some tips on GOC. Kanika, I have taken the web series called Epic GOC. You can search for it on YouTube, just watch it, and then you'll realize GOC is very easy. There are no tips or tricks to it. It's just that you need to understand the theory and solve as many questions as you can. ठीक है? Yes, Aviral. After GOC, you can start with the mirror on the wall series. Mirror जो भी series है वो नाम उसका. Yeah. So yes, you can see the mirror series, and after that you can start with the basics of reaction mechanisms, then alkyl halides, so on and so forth. ठीक है? तो हाँ. You can watch as many as you can, as many as you want in 11th, but basically you should watch the Epic GOC mirror on the wall series and then basic reaction mechanisms in 11th class. That's what you should do ideally. ठीक है? चलो. Badhiya. Cool. So people, that's it for this class. Thank you so much for joining in. If you have any more questions, queries, comments, please leave it in the comment section down below. If I get time, I will definitely revert back to your messages. And in case you liked this particular session, please make sure you hit that thumbs up button. Please stay subscribed to this channel, because I'm going to see you tomorrow at 7 p.m. continuing the idea of ionic equilibrium, and we'll become experts at this chapter very soon. Until next time, take care.